GCMP data is also there. And there's no reason in principle why we couldn't have more radio data there. That's something we've been talking about internally in the context of ALMA and making ALMA data more widely accessible to the world, and just making optical people think, because when you just do a search on your favorite target, if you suddenly see, hey, GBT also looked at this region, that's cool, maybe I should delve into that a bit. You know, they might not be thinking of looking for radio data, but if they see it exists, then they might get their feet wet. So I think that's something in general we should be thinking about in longer wavelength data.
Larry, can I ask a
Please do. Yeah. Sorry, everyone will speak up as and when you feel that.
So somebody may or may not, I don't know the answer to this. Jim, maybe you might, but the new telescope timeout allocation tools that are being built for the proposal system, right? Do you know if it's jacked into the NRAO archive so that when you input coordinates for your proposal, it would be great when it does the SIMBAD resolve that it will inevitably do, if it could also have a button right next to it that says search the archive and see what other observations have already been done using whatever facility you're proposing for.
I like that idea. I'm not sure if that's being built in, but it ought to be.
But at this, I mean, there's still early enough in the process that they might be able to add something, at least in phase 2. That would be fun, and that would address Jaime's point, I think, about accessibility, about at least advertising.
To at least those
to
proposing
those
on GBT.
Proposing for that. Andrew has recommended a tiny little GBT-like clippy that says it looks like you're trying to do a GBT ammonia survey. Would you like help with that? Great.
I like that.
So an antagonistic question possibly. So have we gotten enough ammonia data now?
Of course not. I'll start with that one. So look, yes, we have a lot of data, and I think the comment was made that it's not all ingested, it's not all analyzed well, and there's a lot more to do with it. But we've seen what can be done, and ramps did 20-ish square degrees. There's a lot more square degrees in the galaxy, and we stopped. So it's a question of what do you have diminishing returns by if you double the number of if you double the area or double the number of clumps that you see, do you double the science? Probably not, but you do increase the amount of science. And some of these statistical arguments where we're kind of on the edge, do we see what I didn't show is the protostars versus the protostellar sources versus the quiescent sources, and are they hotter? Are they more? Well, it's kind of on the edge, right? It's a 2.5 sigma result. Some of those statistical results could really benefit from larger samples. Some of the stuff that Jaime was doing, I would love to see more of that. Those islands of calm seems to be a thing, but how many sources are in there? Half a dozen, right? So wouldn't that be great to get 20 or 30? And find that this is the way nature works, and God made islands of calm, and that's how stars form. That would be amazing. But I'll let him answer that. But yeah, I think we could benefit from more. And look, in the terms of the finding chart aspect of it. So we did something similar in the south with not in ammonia, but with the millimeter lines with the MACRA telescope. Looked at 3,000 clumps. So we've identified then the 50 most massive cold clumps, and made that the basis of a interferometric survey. You can easily imagine doing that with the data that we have. But we're finding how many G23s are there. So we found one bizarro source of a supernova interaction. I'll bet there's like 1 or 2 more in our data. I would love to find a dozen of those. So I think following up on some of those interesting targets, you might consider it philately, but I think it's pretty cool that we can identify these rare objects, and more would always be better. I'll let Jaime.
Go ahead.
So I can say that at least the way gas was set up, it was the shallowest survey that we could do, because we really wanted to go very fast, very quickly, to make sure that we detected mostly the ammonia 1 in most places as fast as possible because it was the major improvement compared to previous with the previous capabilities. And I think that now that we know where we have detections, for example, now it makes more sense to just go to more to do more localized, like a smaller area follow-up and say, okay, in this case, what about these lines? We didn't detect any of these carbon chain molecules in some regions. We saw them in other regions. Is it because we didn't integrate long enough? Are the abundances just lower in these regions, for example, or the temperatures? In some cases, we could get the temperatures mostly in the cores, and we were missing the temperature of the cloud. And trying to see if there was a major change in the temperature between the surrounding environment and the cores, that also plays a role in both the chemistry that is outside the core, but also if there is some external heating that we need to take into account in trying to understand what's going on in the cloud. So I think it makes sense to revisit some of the regions and just go deeper. Maybe there are more chemistry-oriented projects, like try to do more like fractionation studies. Now that we know where everything is bright, now we can go and do the proper follow-up.
Sorry, Pedro, yeah, if you tell me if anyone has their hand up as well.
Yeah, there was a comment from Tony Minter about the time requests for the KFPA going down from 2,200 hours in 2014 to roughly 240 hours. A lot of data.
I think it's because the three of us are saturated.
Yeah.
It's the shame. So I think at some point it gets to the point where you really need to publish all, I mean, a big fraction of the data you already have before feeling the need to request more data. Otherwise, I can imagine the tag immediately is giving that comment back, like, come on, you need to publish the rest of your data. What are you doing? I think it's totally fair comment.
Sorry, I'm going to get to you, Helen, but I wanted to follow up on something Jaime said. So Jim, on the ramps survey, I noticed a very large area of nothing.
Yes.
There. So should you go back there and go deeper?
No.
No.
No, I don't think so. Look, so we found that actually continuing the map was actually more efficient than zooming in on the 8,000, say, bowl cam sources in the area, because the settling time is so long. To, on a small map, you move, you settle, and you move back, and settle. That settling time is more time than if you just kept the telescope moving. So it's actually much more efficient to map these large areas. But you're not. You kind of know where you're going to find ammonia emissions, where you find the dust emissions, right? So you kind of know where you're going to see flux. And we did target kind of the busier bowl cam areas when we realized we weren't going to map the whole galactic plane in the time allocated. So we chose kind of the busier areas that had the most number of bowl cam sources. There's still plenty to do, but I think the blind survey is you might as well map if it's more efficient to do so than just targeting another 10,000 points. I could easily see extending it to Helicos 50, or maybe even going into Cygnus. Going into the Galactic Center would be cool, but that's probably a different project.
So Helen, back to the original question. So did Keystone achieve everything it set out to do, or do you need to do? Should you do more?
I don't think we quite mapped everywhere we asked for, so that's an easy part. But also, the emission was sparser than expected, and I think there are hints that there would be ammonia lines if we integrated deeper for a lot of. So we targeted AB equals 10, expecting to see emission in most of that area, and less of it had easily fittable lines than expected. I think the line fitter could be improved to do better in the very faint areas, but I think we would also do better just going deeper. I think we get a lot more emission that way.
By the way, Jaime, I wanted to point out something to you. When we were doing our ammonia fitting, and we looked at all the residuals from all the sources, and there was this big fat residual. So we're seeing this broad component as well in the ramp state. So it's there. We thought it was some mistake. Looks like it's right.
And the good thing about the GBT is that the secondary, the error beams, they are much smaller. So it's not like we are worried that so much that it's picking up emission from a nearby
That's right.
nearby
It's very
gas.
radiation. And the baselines are super slow.
Actually, that was a question I thought of earlier. So Helen, I'll go to you first this time. I think all of these surveys had lines other than ammonia that don't get mentioned a great deal. Did you see much of interest there?
Yeah, so not as much time has been put into analyzing that for Keystone yet. But I was talking about that with James yesterday, and not a lot is seen. Now, maybe we can do clever things by binning up spectra, you know, kind of increasing the signal a bit more. But the data as it is, the higher inversion transitions of ammonia are typically seen in absorption towards some of the brighter continuum sources. But really, it's just the ammonia and the water maser that right now, without doing cleverer things to the spectra, that we're seeing much.
In our case, we did have regions where some of the carbon chain molecules were brighter, and that's, for example, one of the TMC1. That's very bright in carbon chain molecules, no surprise. But I think that line is much fainter than the ammonia lines that we are targeting, and therefore I suspect that we're missing a lot of that emission because we were going so quickly. And in terms of science, one of the ideas that we want to look at is the ratio of, for example, some of these carbon chain molecules with ammonia in terms of abundance, and try to see if there are any signposts for evolutionary chemical evolution. Basically, there are some proposals that suggest that maybe some of the carbon chain molecules would pick up, would have a higher abundance before ammonia gets to the maximum of abundance. So by just taking this ratio, you could try to see which cores or which regions would look more chemically young or chemically old, relatively speaking.
Yeah, and ramps, our survey was pretty shallow. We were going as fast as we can to cover as much area as we could, and our typical clouds were 3 to 5 kiloparsecs distance. So these other lines rarely showed up. About 10% of the sources showed ammonia 3,3, maybe 5% ammonia 4,4, 1 or 2 maybe showed ammonia 5,5. We saw one of them today. The exception, of course, is water, and I think Helen made a nice point that, you know, water masers are, that's a whole nother project. We detected something like 790 water masers, and about 500 of those were new. So there's a lot of water masers out there. When we were looking at, you know, where they come from, about a third of them came from AGV stars. So you can see on the infrared maps an AGV star. So there was we were detecting a whole bunch of new masers associated with AGV stars. Another quarter or so wasn't obviously associated with any ammonia emission. And that's weird. So where are those coming from? Don't know. They may be distant star forming regions that we didn't have the sensitivity to detect ammonia. They may be distant AGV stars. They may be something else, but there are at least a quarter of the water masers that had no known associations.
There was a question from Tony about the 15 to 14 ratio of nitrogen.
Oh, yeah.
If there's anything that the ammonia surveys could help to provide information on this ratio.
I didn't target any of the 15 ammonia ones. So we just chose our limits. I don't know if the ramps are gas or keystone.
We did not target 15 ammonia, but we know that to detect 15 ammonia, you need to integrate a lot longer. So in that case, it could. Unfortunately, it doesn't make a lot of sense to just stare with the KFPA because then all your beams move on the sky. So it doesn't help to have a map. So basically you just get a single measurement that is very deep, and then everything else is super noisy. So it would be much more interesting to, let's say, to have maybe small maps with the Lisa-U mapping, for example, where you are very efficient, or maybe even having more flexibility with how many windows you're going to put in there. Because if you're going to integrate that long for the 15N version of Ammonia, then it makes sense to also target some of the other faint, interesting lines that you might be interested on. And in that case, I think it also makes sense to think what could be the next steps in terms of upgrades for the spectrometers, basically, and looking forward the next few years, and also planning for the NGVLA.
Ammonia is a bit different than the CO lines in this regard, right? You usually go after the CO isotopologues to get optical depths, but ammonia gives the optical depth for free with the hyperfilms. So that aspect of it is not really the driving science. Now, if you're interested in nuclear processes where the 15N to 14N ratio is important, that's cool. But that would be really hard with a survey because the lines are so very faint.
All right,
Nothing to
Jim.
add on the Keystone end. We had the same setup as RAPS did, so we did.
Good choice.
I'm going to ask you your own question, Jim. If you had a 100 pixel array, how long would it take to do an all sky Ammonia survey?
All sky. Wow. All right, so all sky is what? How many square degrees? 4,000.
Anybody remember VLAX's area?
So, we did 20 degrees in about 500 hours.
Okay.
So a factor of 200 larger and a factor for area and a factor of 10 smaller for number of pixels, roughly. So, 500 times 10, 5,000 hours.
5,000 hours. So spread over a decade as a legacy project.
But there's no point looking above the plane. I mean,
Okay, so you can be selective about particularly where you want to
you
do
could
it.
do the Milky Way survey.
Reproduce the CFA CO survey area, sure, right, with 100 pixels.
Yeah.
Right. So
That's
why not?
doable in 1,000 hours. Sure, that would be the project, right?
Right.
Everyone would agree that Helen would love that, and Jaime would love that, and those teams could be able to do their science. Just a question of how deep you want to go, right?
Sure.
We were pushing the telescope as fast as it could go.
Yeah.
But yes, an ammonia galactic plane survey would be doable in a reasonable amount of time for a large project.
With the 100
Well,
pixel.
100 pixel.
Well, but it could be like LSST. You have regions where you go much more often, and then you build up the sensitivity where you need, but you are all the time moving, and then you could cover the whole sky, I don't know, in a couple of years at the depth that you wanted.
I don't know if there's any interest in high latitude ammonia. I mean, I don't know. Has anyone ever seen ammonia toward a high latitude cloud? I have no idea.
There's Jay.
I mean, they're definitely seeing molecular stuff.
Yeah, you've seen CO lines.
Mm.
Maybe. But with 100 pixels, you could go really deep as well. So those sorts of projects might do ammonia and high velocity clouds. Sure.
But with-
There's not very many atoms in that molecule.
Sorry, but with a 100 pixel array, how big would the footprint be?
Well, you imagine you would fill your field of view. I'm looking at Steve now, so he's going to build this thing. So
So going in as a focal point array is impractical. You go to the world of phase array feeds, which are fully sampled too. There's not holes in there where you have to move back over so you could scan across the whole focal plane without moving around. So you have to factor that in, but scale is, I'm not sure.
Well, I think it's, the proposal, the white paper we wrote was 7 times the size. It was, yeah, well, it wasn't quite a factor of 10, but you get a 215 beam phased array with that design. But it was not quite as much faster as you think.
I mean, yeah, it works out about a factor of 10.
In mapping speed.
In mapping speed, the two
On the same system.
I wanted to ask the surveys if they're about their data reduction tools and well, what did you use? And then if those tools are available to anyone, like if I want to do an ammonia observation right now, can I just throw my data to your pipeline and get results?
I'll let my colleagues answer first.
Um,
What tools?
So basically, we with Eric and Adam and Rachel, we basically made a pipeline, data reduction pipeline, where we have basically the observing log with all the information needed for the GVT pipeline to run. So it's a big wrapper that if you have such an observing log, you can just run it on your data, as long as you have the same setup as we do. And then basically you can just run the pipeline. I've done it for other projects. I've just tried to modify some commands for the gas pipeline. I'll just run it for another project and I can get it. It's just, thankfully the GVT pipeline works really great for KFPA data. I think that the main concern that I would have would be with making sure that the calibration is up to date in terms of the noise diodes and the aperture efficiency, that kind of things. But yeah, you can reuse the tools.
Are you talking about the calibration and pipelining tools or the analysis tools?
The calibration of pipeline.
So we, my graduate student Taylor Hogg wrote his own pipeline. I mean, it works, and you can change the line and create all the cubes that you need for the line of interest. So once he made the calibrated bits cubes, he ran it through PySpec kit and had some wrappers for that. And so all the ammonia fitting was done through the PySpec kit ammonia fitting processes.
Helen, did you use the same stuff?
Yeah, Keystone just shamelessly borrowed mostly from gas, so nothing to add.
There were some upgrades along the way that we retrofitted. So
Many
there
thanks.
was yeah, synergy. But it's all on GitHub. So if you want to take a look at what that pipeline is doing, you can go ahead, take a look at the pipeline, clone it, modify, and run it.
I will say it kind of points out a bit of a deficiency in the green bank world, because it would be really nice to have a pipeline, spectral line data processing pipeline that everyone can use. Just a lot of effort to do it. And the argument I keep hearing is that, well, every project is different. Well, not every project is. Our 3 projects are very similar. We could probably use each other's pipeline. We do, right? So it's doable, but it will be a lot of effort. But I'm getting push from above that science-ready data products are in green bank's future. So the users committee has made their voice loud and clear.
There's something to be said for, you mentioned, right? The large projects in a way all kind of have certain pipelines. Could, at least when you have large projects, they share their pipeline, at least making that sort of thing accessible.
That's right. And
as part of their data process.
And it's part of the archive too, which you don't want just hear all the data cubes and have at it, right? You would really like some just rudimentary tools to extract the area that you want or the volume you want from the data cubes. I'm not interested in this giant, 5 terabyte data cube. I just want my little chunk that's around W49 and I just want to analyze those data. I want this velocity range and this LMB range. And the ability to extract an image and just have a cursory analysis of a small subset of data would be very useful.
I mean, Audi has that capability for all my data. It can re-image on the fly, but can you select a chunk of a data cube like that? Yeah. So,
But Carter, I mean, if you have a bits file, Jim, Carter should be able to open it. Eric, if Eric's still online, you could, if you have an image cube for any of these data sets, even if it's a 5 terabyte cube, if it's a FITS cube, Carta should be able to view it. You can zoom in and all kinds of stuff in there. So visualization is not the problem, as long as you have Carta integrated into the archive.
Yeah. So I've got a question that is a little leading, but so in Helen's talk, she gave this great summary. The last good few slides of her talk was all of the follow-up projects that are going on using Keystone data. So two questions really. One, well, let me just put it this way. So either what enabled Keystone to be able to do that, or do ramps and gas also have that, but it wasn't made as clear? Is Keystone special in that there are all these follow-up projects, or do gas and ramp also have those? And if it is just Keystone, like what's special about Keystone?
Keystone has like enthusiastic manpower. That I think is part of it. You've had a lot of good students doing their thesis work. I'll let Helen answer, but I think that's really the answer. You've had a lot of people looking at the Keystone data and working.
I would have said that gas benefits a lot more from that than Keystone. We've had, I mean, gas has been around longer, but there's been a lot more student involvement so far with gas than Keystone. I think James has been very good at pushing everyone on the proposal to like advertise to your friends, use our data and tell me about it when you use it. But I'm sure there's lots of people using both other data sets as well.
I'm sure there are other projects to do ramps, so I'm sure there are other projects to do.
Well, Eric said, there are 20 more papers to be written from gas.
So, I mean, to get to Tony's comment earlier today, right? The pegging of the temperature using just 1.1 and 2.2. Oh yeah, I mean, not a lot of sources, but enough of them have 3.3 and 4.4 and 5.5 emission, right? And so I showed in that supernova interaction zone, the 4.4 and 5.5 gave a totally different answer than the 1.1 and 2.2. Coming from different velocities, they were tracing different regions. So there's a project there from those sources. I want to find more 3.3 masers. I think those would be easy to find. I'm just looking for spikes in the 3.3 spectra. So there's a lot of and all these other ones. So we included some methanol masers. We see them occasionally. We didn't really take much of a look at the methanol maser. So and the whole water maser analysis. I mean, it's all great. Here's a catalog of water masers, but what does it tell me?
Well, yeah, I mean, I wonder who should do this work for it. If there's not the manpower on the survey teams themselves, and by the time you've done a survey, a lot of people have moved on.
Oh, yeah.
So especially the students.
Right.
So how do we make this happen?
Well, surveys are big production lines. I mean, there's a lot of work that just gets into getting the data out. Observing was 500 hours of observing. That was a slog. It was a real slog. My colleagues can speak to that. But it is when the length of a survey kind of equals the length of a PhD thesis. Yeah, you're going to lose. You're going to lose people. Right? So you have to have a steady pipeline. One of the issues, the astropolitical issues, is it's really hard to get funding for radio's projects. And if you have a NASA project, time equals money. So a lot of people go after NASA's projects. And Sophia, for instance, time equals 1 hour equals $10,000. It was Einstein's last equation. It's great. But for this sort of thing, this is kind of this is a labor of love. You're doing it because you're passionate about it, you're interested in science, but it's hard to get funding. Now, we were lucky enough to get some funding for ramps that got my students through, and I had a postdoc working on it for part of the time. But it's just these sorts of projects are it's difficult to get funding. But I'm sure Alma suffers from the same thing.
Sort of.
Okay, well,
Well, I mean, geez. Do we talk about this here about student observing support or not? Because, in Green Bay, when split off, right, this independent of student observing support now, but VLA or Alma have student observing support available, so you could fund a graduate student for a period of time. We also have the Alma archival student observing support now, where you don't even have to have a project. You go into the Alma archive and search for it. So we should start talking about whether or not, GBO kind of participates in this kind of stuff again, where you could fund a student for a period of time, a year or two, depending on land length of the project. Very successful in the past. The officer subscription is relatively low. It's not a ton of money, but it helps.
Yeah. I don't know if Jaime and Helen wanted to.
Yeah, I was gonna say, Jaime, who's gonna write these 20 papers?
Better
So
get started.
Yeah, I have to say that, for example, for us, what took us quite some time was to get a mature pipeline that was able to process all the data, and after fixing all the issues with either calibration or making sure that, for example, the calibration was stable over different months. So at the end, it took quite a while for us to really have a mature pipeline to just run the data. And I think that, on the other hand, Keystone was able to get started with a pipeline that was already running, more or less. So they were able to take that as an advantage, improve upon it, and get ready when the people were still present, right? I think that's one of the main issues, that as you get people into the project, then if they don't get the data quickly, they get busy with other projects, and then you just need to build up more momentum again. That gets a bit difficult. So also COVID didn't help. So now we just need to get back into meeting at least in person and trying to organize again and try to get our priorities straight and decide what are the key projects for example, students that we're going to be offering again. So
On this regard, I have a question for Helen and Jaime. Do you get a lot of hits on the Dataverse? Are a lot of people using your survey data?
I don't check the statistics, but I know that a lot of people are using it. Even I've seen papers taking the data, trying to do some reanalysis, or taking the data as a zero spacing for VLA combination. So I think that in terms of users, we are getting a substantial amount of extra users outside of the survey.
Yeah, I haven't checked the stats either, so I'm not sure. I mean, I think in general, James has been trying to keep in touch with anyone who has expressed an interest in the data. So that's why I was able to present so many different people working on it, because James just keeps poking people to say, what have you been doing with the Keystone data? It's a sort of an informal, non-quantitative way of checking it. Yeah, I don't have anything more quantitative than that.
But I would love to see that, one of the reasons I'm so keen on this archiving project is to grow that archival user base and to bring in some people from other areas who may not be experts in radio or remote data. Yeah.
So can I propose, for any of these large key programs they have, and you have 20 papers coming out, we will more than willing to support press releases, conferences, special editions in AppJ, those kind of things where, are done large programs, for example, always got some kind of large special edition recognition in AppJ. They always were accompanied by press conferences at AAS or press releases that came out with a large release data set. Use us for that opportunity, especially if you think you have a large number of papers coming out. We'll organize that around a big press release and a big press conference. Hopefully at AAS do that, so please do that. The other thing about the pipeline, Jim, is like, we started with ALMA and they said you'll never be able to make a pipeline for interferometric data. It's not going to happen. It's impossible. People need to run their hands through the visibilities to understand what's going on. It's just a matter of doing it. Ammonia is ammonia. It's still at that same frequency. It's been there forever. It will continue to be there forever. So
Just the beginning of the universe.
yeah, we just built, well, it depends on whether or not the concepts of the universe are changing, but that's another argument. But just we build a pipeline around that and just say, if you're going to do the big ammonia survey, we just put the resources behind, this is the way you have to set it up. You have to do this, 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 and then boom, you get pipeline data products out. Yeah, it was more of the making things automated from the beginning to end, from proposal setup all the way through execution. You didn't have a whole lot of flexibility. You do have flexibility in the ALMA system, but you don't have the flexibility that you could tweak with everything, and that's how you make a pipeline. Jim just yelled at me. He's trying to yell at me.
I just wanted to say, we did have a pipeline for GBT spectral line work that was a project going on several years ago. Joe Masters was the software engineer behind that, and I was offering some scientific advice, and we were working with the ammonia groups, and Rachel was involved. And I think that experience could be improved on, but in the end, the science community was more interested in creating their own pipelines than they were in using an observatory facility pipeline. And I think it's because there are just special needs associated with it. So if that were to be something that were of interest going forward, there are certainly lessons learned to be drawn from, but you'd want to make sure that that's really what the community wants before you devoted serious resources.
Well, our pipeline is just a wrapper on the calibration side. It's just a wrapper on the GBT pipeline that Joe Masters wrote. So in that sense, we do use the observatory resources, but there is, for example, the imaging, the gridding part, the GBT gridder. It appeared later. I think at the beginning it was mostly using the APES gridder, which wasn't never very efficient or nice. So in that sense, that's why we ended up also using a lot of the pipeline development for the imaging itself. But the calibration, it's all a big wrapper around the GBT pipeline, which made things easier, a lot easier. But for that, I think it could be expanded to be easily applicable to any data on the archive.
So I think Jim makes a really good point that a lot of the existing users probably want to do their own thing. To offer a bit of a counterpoint, actually, Tony and I just got emailed 2 hours ago or something, a paper from a European group that we talked into using the GBT, and they weren't going to do it otherwise because there was a huge activation barrier to. They were intimidated by the asterisk scripts, they were intimidated by the observing, and they were intimidated by the data reduction. And so I was just their pipeline. I said, look, we've done this for Gotham. I already have the scripts, the observing scripts set up. They feed directly into my data reduction pipeline that I use. And they said, fine, we'll do it if there's a low activation barrier. And it's a great paper. It's great observations of Bell 1544 at lower frequencies. And it worked out great. So I think there's an opportunity to bring in new users, especially in this era of being able to do things either operator driven or remotely without having to fly here to get training. If there is a, plug in the lines you want to observe and it will generate the scripts for you and the data reduction scripts, at least for a, 90% of what you want to do with the finished data products. But that is for new users. I totally agree with Jim that I want the flexibility as well as an experienced user to do the bespoke observations when necessary. So it's a balancing act.
It's not an either or situation.
Right.
Yeah, I think that's fair.
It's maybe a question for Wednesday's discussion, but I think Jim made a good point. He said, well, you need to ask the community what they want. Well, this is everyone I could get to attend this meeting. It was a GBT K-band observer, so what do you want? Do we want front-end reductions if it means constraint? Well, you just said it, but you know, on the whole, yeah, go ahead.
I'll make a comment on that. Hi, guys. I'm on the soccer team. I just started. If you guys want more front-end stuff, please make more of a fuss, because I want to
I mean, if it means constraining what kind of observations you can do on the proviso that you then get handed data cubes at the end, is that what you want? Or I mean, given that you would probably still have the freedom.
Yeah, as a bespoke user, I would use that if there's if there's an option, either if you want the data products at the end, you live within our constraints. If you are happy to just do it yourself in GBT IDL, then fine, right? You can do whatever you want. But I would love that, to be able to just plug in my easy Vegas observations and go.
Even if it's just something like Tony said, like when you go to do your proposal, you can say, do you want the vanilla version? In which case, we'll do it all at the end, from beginning to end, we'll help you guide. But if you're an expert user, you can check a box and say, I'll take care of this, don't worry about it.
Well, I tend to disagree in that sense, because then you're blocking out all the non-experts from using that data if it's in the archive. So you do want to make sure that all observations can be pipeline reduced, like just the same way as ALMA. There is the images, at some point the images at ALMA, you cannot use it straight away in some cases, and you just reprocess them, and then the expert user can use it. But in the case of the GBT, I know many people were when they are asking if there is data available on the GBT archive, then if they find something, then there is no way for them to retrieve it if they don't have a GBT account to process the data in the GBT machines, for example, which makes the whole process absolutely extra complicated for no particular reason. If you want to get more users, more random users instead of just your niche core users.
Yeah, I mean, it's a fundamental shift in how Jim is going to run operations here going forward. I mean, and we have, I want to say, you have to market this, right? It's going to be get out there and market what we're going to offer. I mean, Jim Jackson here, or Jim Bros, but Jim Bros probably did it too. But you could hire a couple students, just do a big scrum session in summertime and just say, reduce every single data set, provide data products at the end, and so people can just download FITS files, fully calibrated FITS files in the end, and you just, yes, there's 20 years of GBT data available, but a lot of it,
We don't know what it is. Right?
yeah, I don't know what it is, and it's really hard to find. It's very difficult to find, and that's why I end up just reproposing for things I may even know it's already there, because it's really hard to get at.
No.
Yes. But this is it's a fundamental shift in how you want to do things, from a relatively you do what you want, this is your facility, this is your telescope, do things you want, maybe we'll archive it, to shift to we're going to make science writing data products. I know our high level data products don't use science writing, just don't use that word. High level data products, something that you're going to be able to just do, hopefully be able to do science on. It's a fundamental shift in how we do things here in Green Bay.
Helen showed a nice example of a community coming in to Green Bank that would need our data, but doesn't necessarily want to go through the pain of learning it and reducing it. So to me, the magnetic field world and the polarization world really needs our limits. We need those velocity dispersions for that, Davis, Chandrasekhar, Fermi estimates of magnetic field strength. And where else, I don't know if they're willing to go through this, what you call the activation barrier to get there. So it's, you can collaborate with someone and, that's a valid path. But, I see that kind of community, which is growing as a new segment of GBT ammonia users.
And I'll just chime in, talking with our CADC archive folks here in other contexts. They said, in the primarily optical data, but I imagine it would translate. When they've archived data that have gone from sort of, you need to do a lot of stuff to it to make use of it, to like, it's already ready to use, usage has gone up by a factor of about 3. It's something of that order. Like it's multiple times the usage. So you reach so much of a bigger community when you make your data relatively easy to use out of the box.
I love someone gives a talk about, we have data back in the VLA archive from 1979 or something like that. It's like, has anyone actually gone back and tried to calibrate and image that data? I would love to know how to do it. Some data from the GDT from 2000, 2001 may not be worth saving, but I mean, the data that I took in, 2007, 2004, it's still very valid. It's very useful. And it's relatively easy to calibrate in. Who knows? You got a question?
Oh, I wanted to say, I think that last or a few falls ago at the Argus meeting, we talked about like there's these documentation forms I think would be very helpful for like quick looks or like, hey, you want to detect ammonia or this is how it was done for B5 and have step-by-step like instructions that way, or hey, you want templates.
Yeah, so we're in the process actually of creating quick guides for as many receivers as we can. And so we have just a KFPA mapping one up that we use in our training schools as well. So we're working towards creating those, and hopefully we'll be getting out more soon. And it will walk you through. This is, if you want to observe this, you will set up your script exactly like this. This is what your data should look like, and then this is how you reduce it. So it's
I think those
streamlined.
if those were more, I like put those on the proposal guide sheet when you send it out, because I don't see it being highlighted, the ones that are available. I know that they're not complete, but I think those are super helpful from the ones that I've seen.
We're working through them on a case-by-case basis.
Right, because I know that it's still harder at the high frequency, but those would be super helpful. And I also think we talked about magnetic fields, having the joint Sophia and GBT probably helped a lot, because I know I had a proposal to do that, helped bring people into the GBT maybe, and having continued, I know we're Sophia, but having continued like maybe collaboration with other telescope, having a joint proposal type system like that could also pull people in.
We have a few. We don't get a lot of customers that way, but we do have a few.
Yeah.
Sophia was one of them, but we can't take Sophia.
I know.
Well, I think again, having the, to Sam's point, if there is the ability to make GBT observations, at least simple ones, accessible, then, if there's, I know joint proposals with Hubble are possible right now, right? And I don't think there's a high volume of them, but think of it from okay, hold on. I'm a radio astronomer, and optical astronomy is scary. If I was going to put in one of those joint proposals, I'd be terrified because I have no idea how to set up a Hubble proposal, and it's really intimidating. And I can imagine from the other side that the optical astronomers are saying, I don't know how to use this crazy metal monstrosity on the ground, and so I'm not going to put in a joint proposal. It's probably a barrier that way too. So if we can lower that barrier, we can, through the joint proposals, probably bring in people.
Yeah.
Great.
There could be a lot of interesting follow-up with Hubble or JWST.
Yeah. And both of those pay money, so that you don't have to.
If we want to look at the, protostars that they're looking at ISIS and JWST and follow up with GW. Yeah. Great. That'd be cool.
Or ammonia, of course. Ammonia. It's the ammonia session.
Sorry.
Yes, yes.
Okay, well, that was a full hour. I think that was a good discussion. Anyone feels there's something more we can push on with, then please bring it up now, otherwise I'll bring things to a close.
Thank you, Helen and Jaime.
Yeah, thank you very much. All right, so we're done for there. I'm sorry, Jaime, Helen and Jim, you're still up on our wall of faces for some reason, but I'm afraid you won't be able to join us for our reception and dinner. You'll be missed, as will everyone else on Zoom. Maybe next time. For everyone else, we'll be meeting over at the Science Center at 5:30 for pasta and wine.
Bye. Thank you for everything.
Thank you.